Hello, ladies and gentlemen. This is Mr. Briggs. I'm coming to you from a hollowed out tree where I'm currently hiding from a group of Girl Scouts. I owe them cookie money. Ugh, you do not want to be in the bad side of them. Well, let's get started with our math lesson. It's Data Distributions 2.2, the mean as a balance point in a distribution. Your classwork is on page 32 and 35. You'll do ACE problems 3, 14, and 15. All right, so let's talk our notes. We have the mean as a measure of center. Now, we've done the mean before, okay? That if we take a bunch of values and we add them together and then divide, we get the mean, we get the average. But another way of thinking about the mean is that you can balance out our values. So for instance, I've got 5, 7, and 3 here. And if I do 5 plus 7 plus 3, I end up getting 15 for my answer. Divided by 3, because that's the number of values I have, I get an average of 5. Okay? Now, if we were to organize that as a line plot with 3, 4, 5, 6, and 7, you'll notice that I have a dash here, a dash here, and a dash here, and directly in the middle is my mean of 5. That all of my values, if I were to look at them numerically in terms of value, balance out perfectly on that point. This also happens to be my median. That's another lesson. So here we've got an example. It's straight out of the book, where we have sugar per serving in 9 cereals. And we have the mean as 8. It's stated as 8. Well, why is it stated as 8? There aren't a whole lot of examples of 8. It's obviously not the mode. And it seems like there's an awful lot that are 12. We would say that 12 should probably be the average, or something close enough to that. However, we have this value down here of 2 that is an outlier, and that's throwing us off. And we can see how these outliers affect our data in the next example. By making that into a line plot, you can see that we have all these different cereals, and our mean calculated out is 6 grams of sugar. Well, I've got one cereal here that is 1 away from the mean. I have a cereal here that is 1, 2, 3, 4 away from the mean. I have one cereal here that is 6 away from the mean. If I add those together, 1 plus 4 plus 6, I get 11. Okay? All these values together kind of pull down 11 in this direction. I have a value here that is 1 away. I have a value that is 1, 2, 3 away, another that is 3 away, and another that is 4 away. And if I add those values together, 4 plus 3 plus 1, I also get 11. So what the mean does is think of the mean like a scale. And wherever the mean is, we have to have values on one side equal to values on the other. Now that's not instances of values. If we have an outlier that's way, way, way off there, it will pull the scale one way or another, such as this 12 right here. It's pulling the scale in one direction. So understanding how an outlier can affect our mean, understanding what it means to have these values balanced the way they are, helps us to understand our data. Okay, once again, our classwork is on 32 through 35, and our ACE problems are 3, 14, and 15. Have fun, ladies and gentlemen.